Okay, welcome everyone to the Masonry week. I know last week in wood was pretty busy. There's probably a little bit too much material. You're going to find this week Masonry and next week steel and concrete just probably a little easier. But I think it's important to keep up to date, keep on top of the work, really enjoying most of your posts. Some of you probably could have written a little bit more last week. The detail wasn't there in some of the posts, but maybe that was because there was a lot we had to do. So I want to go over a couple of sort of misconceptions. So remember, we have columns, and typically in Greek temples columns are made out of stone because stone is very strong in compression. You can have a beam or lintel out of stone, but there's a limit to how wide that can be, because remember, when you have a beam, and we'll use this as an example as a beam, imagine this is the top of the beam, this is the bottom. When a beam bends, you can see that it is in compression at the top and tension at the bottom, and stone is very good in compression but very weak in tension, so it will crack here. So there's a limit to how wide you can have a stone lintel, because otherwise if you hit it hard enough, let's see if I can get this to break, yeah, that'll happen. It will literally break. Now you can span a larger space using wood as a beam, and that's great, and that's what the Greeks did. That's why you used wood rather than stone, because wood is good, strong in tension and compression. But the problem is it's going to bend, and ultimately if you go too far it will also break. So there's a limit to how wide you can have the cellar or that room in a temple. And the way the Greeks got around that was by putting more supports in, by adding new columns, putting new columns inside. This is not really the right height, but you had to add supports inside the cellar, rows of columns, because there literally is a limit to the largest clear span that a wooden beam can support. So remember again, because a beam, both compression and tension is happening. Then someone invented this here, and this is the truss. And the advantage of the truss, which was mainly used by the Romans, is that you can span a huge distance, and you don't need a long piece of wood. You can make a truss out of lots of shorter pieces of wood. And the key thing to note about a truss is that unlike a beam, it's not bending. Each segment, like each element, so this portion up here, or this portion here, or this portion here, is either in compression or tension. So here's sort of a diagram showing you some of the compression and tension in a truss. So a truss is not going to bend, and you can span massive, massive spaces using trusses. Compare that to the narrow, narrow confines of a Greek temple. And so a truss can be much lighter, it can be made out of smaller wood, it can span a much bigger area. So it's a major, major engineering feature or invention that transformed architecture. Now there is another way to span spaces if you don't have wood, because the problem with wood is it can catch on fire. So that's the focus of this week, and let's have a look at our little model over here. So I want to demonstrate, one of the things we're going to be looking at this week is arches. Now arches are typically made out of stone, and I am going to quickly build this Roman arch here. Hopefully you can see that okay. Now because it's made out of stone, we know that stone is strong in compression and very, very weak in tension. So there is no tension in this. This is completely made out of the forces that are in here are just compression. This last piece is the critical piece. It's called the keystone. It's going to fit in top. And then I'm going to take out my wooden framework, and what you will see is the arch will settle like so, and now I've got a stone arch. And I can actually apply a force to this, and it is pretty strong. Now you'll notice though I'm holding my hand here, there's something that arches do need, and we're going to discover what they need, because I can put a lot of force on here. Notice I've spanned this area using stone, using the arch, but if I put too much force on, something will happen to the arch. So this week we are looking at masonry. We're looking at stone arches. If you look down, here's my finished driveway. I'm pretty happy. This is also made out of masonry. One of the things you're not going to see around this area in California is a lot of brick. We don't really build in brick, and you can probably guess why that is. It's because we have a lot of earthquakes. Just as some of you struggled last week to find buildings made out of wood for obvious reasons, we don't have a lot of brick in California because it's just structurally not that sound of an earthquake. So have a good week. Look forward to reading your discussions and your posts, and I'll see you later on. Bye.